The topic of my lecture is Ultimate Analysis of Coal. I am Dr. Sangeeta Krishnan. Now, before we start with the ultimate analysis, let's start with the fuels. So, fuels are substances which are made up of carbon, which is their main constituent, and they react and release large amount of energy. Now, the solid fuel is divided into three parts. First part is the analysis of coal, where we have the proximate and the ultimate analysis. Next is the determination of HCV and LCV. The third is the manufacture of coke. Now in this we will be dealing with the analysis of coal and preferably the ultimate analysis of coal. It is known that there are two types of analysis, proximate analysis and ultimate analysis, but in this lecture we will be discussing only with the ultimate analysis of coal. Now in the ultimate analysis of coal, the elementary composition of coal is analyzed in terms of percentages, that is the percentage of carbon, the percentage of hydrogen, the percentage of oxygen, the percentage of sulfur, the percentage of nitrogen and the percentage of ash. So these are the various percentages, as you can see, the carbon and hydrogen. Then we have nitrogen and sulfur. Then we have ash and we have the percentage of oxygen. Now there are individual tests, unlike the proximate analysis where it is a continuous test and all are determined in one row. Here there are separate tests that are there. So first we will start with the analysis of percentage of hydrogen and carbon. Now as you can see in this apparatus is seen to you. It is for the analysis of percentage of carbon and hydrogen. Now as you can see that this is a tube, and in this tube the fuel is placed, and the quantity of fuel, whatever the quantity of fuel for which ultimate analysis is being done, is first analyzed, is first weighed, and then it is put inside this tube. Now as you can see, this is a burner. Now this is connected to two tubes, two U-shaped tubes. Now in this, as you can see, there is calcium chloride is filled, and before the start of experiment, the calcium chloride, the quantity of calcium chloride is also weighed. Next we have the second tube, in which we have this is for the absorption of carbon dioxide. So as a result, here we fill it with KOH solution. It is filled with KOH solution. Now before the start of the experiment, first of all, the three things are weighed. The first thing that is weighed is the amount of fuel. So this is noted. Then this calcium chloride is noted, which is for the absorption of water. The third weight that is taken is the weight of the KOH, which is filled in this tube. Then the burner is installed, and this burner is heated, is ignited, and as a result the fuel is continuously heated. From here the oxygen enters, and as a result the reaction takes place between the fuel and the oxygen that is there. And here in this analysis we are analyzing two things. All the carbon that is there is converted into carbon dioxide, and all the hydrogen that is there is burnt and it is converted into water. Now this substance from this tube, it passes through this tube, and when it passes through this tube, then all the water which is present in form of moisture, it is absorbed in this tube, and as a result the weight of this tube continuously increases. Then this is made to pass into another tube. Here all the carbon dioxide whichever is present, it is absorbed, and as a result the weight again increases. Now after the experiment is over, then again this calcium chloride tube is again weighed, and this KOH, this tube which contains KOH, is again weighed, and the difference of weight will give us the amount of water that is absorbed, initial weight and final weight. And in the second tube, if you take down the weight, then this second tube will give us the weight of the carbon dioxide. The weight of carbon dioxide will come. Then there is a formula that is there, and the formula is as follows: percentage of carbon is equal to increase in QH into 12 into 100 upon weight of coal sample into 44. Similarly, percentage of our hydrogen, we have to find out what is the increase in the weight of calcium chloride into 2 into 100 upon weight of coal sample into 18. Now this value is taken because here the carbon is being determined, but the carbon is being calculated in terms of carbon dioxide. Similarly, hydrogen is there, and hydrogen is being calculated in terms of water. So as a result, since we are determining carbon in terms of carbon dioxide, that is why it is multiplied by 12 and divided by 44. Similarly, here water is there, so hydrogen upon water. So in this way, putting these two formulas, the percentage of carbon and percentage of hydrogen is determined. Now this is the next test. This is there for the determination of percentage of sulfur using bomb calorimeter. So bomb calorimeter is there, and in this we determine the amount of sulfur. Now if you can see this diagram, now first of all is the name. Now first of all we have the central apparatus. Now this resembles the bombs that were there in the 2nd century. So as a result, the name that is given to it is called as the bomb calorimeter. Now in this, as you can see, there is first of all is this tube, and this is a crucible, and in this crucible the substance is put. Now bomb calorimeter is used to determine in case of solids and liquids. So whatever is the fuel, it is first weighed and it is put inside this tube. Then this substance is connected by these two wires. These two are magnesium wires that are there, and these two magnesium wires are then connected to two electrodes. Now these are the two electrodes, and both these electrodes are further connected to a 6-volt battery. Now in the bomb there is also an inlet, and this is the oxygen valve. This is for the addition of oxygen just before the start of experiment. So we have already weighed the fuel, and this is the oxygen inlet tube. Now this bomb is immersed into a solution. This is filled with water, and before the start of experiment, again the weight of this chamber is taken. Then in this chamber we have a stirrer. This stirrer is there to move the water so that the heat that is released from here mixes and the heating is uniform. And there's another thing which is there, which is the Beckman thermometer is there. This is to note down the temperature, and this is enclosed in another chamber where there is vacuum, and this is the outer part, and this is the copper calorimeter that is there. Okay, so this is the appearance. Now before the start of experiment, two things are done. First of all, this weight of fuel is taken, and the weight of this water, whatever amount of water is there, it is also taken. After this, what we do, through this oxygen valve, oxygen is added. Now when oxygen is added into it, and a spark is generated using this battery. This battery is there, and a spark is generated. So when the spark comes, using the spark and the pure oxygen, these magnesium wires, they start burning. So as the magnesium wires start burning, they start releasing large amount of energy, and as a result high temperature is created, and even the fuel starts burning, and as a result large amount of energy is generated in the bomb calorimeter. Now since the bomb is enclosed in a copper calorimeter which contains a thermometer and a stirrer, so as a result the temperature, the heat that is produced in the bomb is released, and it is captured by the water that is filled in this chamber, and as a result the temperature of the water starts increasing, and before the start of the experiment the initial temperature is noted, and the final temperature is also noted, after which there is no rise in temperature. Then a formula is used. So this is the formula that is there. This is the formula. So the percentage of sulfur, and in the bomb calorimeter, actually the fuel gets converted into ash form, and to this ash some amount of barium chloride is added to it. So as barium chloride is added, a ppt of barium sulfate is formed. So percentage of sulfur is equal to weight of barium sulfate into 32 into 100 upon weight of coal sample into 233. Here again this is the weight of barium sulfur, and this is the weight of barium sulfate, because here also the sulfur is being determined in terms of sulfate. So using this formula the percentage of sulfur is determined. Now the next experiment that we have is the determination of percentage of nitrogen. Now nitrogen is determined using the Cage-Dehls method. Now in this, first of all, a coal sample is taken. As you can see, this is a bulb, and in this the coal sample is taken. It is first weighed and then it is added into it. Now through another tube, gradually sulfuric acid is added drop by drop. So on addition of sulfuric acid, what will happen? The coal will have nitrogen. It will convert into ammonia, and this ammonia will then react with sulfuric acid, and as a result ammonium sulfate will be formed. Then once this is formed, a white ppt is formed, then the burner is removed and this is opened, and barium sulfate is the ammonium sulfate is taken from this tube and it is put inside this tube. Now as you can see here, we have the ammonium sulfate is added, and there is a another tube through which drop by drop NaOH is added. So as NaOH falls in this, the ammonium sulfate reacts with NaOH, and as a result ammonia gas is liberated. Now this ammonia will move from this chamber and it will pass through this. Now in this chamber, as you can see, this is filled with a liquid, and this liquid is nothing but sulfuric acid, and the sulfuric acid is there, and the normality of sulfuric acid is known, and even the volume of sulfuric acid is calculated. So as a result, what will happen? Gradually this ammonia will neutralize the sulfuric acid and neutralization reaction will occur. Once the evolution of ammonia stops, then what we do? Once the evolution of ammonia is not coming, then this sulfuric acid is taken up. Sulfuric acid which is there is taken up, and this is titrated. This is filled with N by 10 sulfuric acid. So this is taken and this is titrated with N by 10 NaOH. And on titration with NaOH, the value which comes will tell us the amount of volume that has been neutralized by the ammonia gas. So in this way the percentage of nitrogen is determined. Now the formula that we have, these are the reactions. As you can see, these are the reactions that nitrogen reacts with hydrogen and sulfuric acid. So in the first Cage-Dehls flask, ammonium sulfate is formed. Then this ammonium sulfate reacts with NaOH, and as a result sodium sulfate and ammonia gas is released. Now this ammonia again reacts with sulfuric acid and ammonium sulfate is formed. Now this is the formula that is there. So percentage of nitrogen is 1.4 into N into V into W, where 1.4 is the value, N is the normality of the sulfuric acid, V is the volume, that is the difference of the volume between when it is titrated with NaOH. For example, if you take 25 ml of sulfuric acid, and when you react it with, so some of it is neutralized by ammonia, and when you take it with, when you react it with N by 10 NaOH, then the value that comes out to be is 15. Then the amount of neutralization done by ammonia is nothing but 25 minus 15, that is equal to 10. So that is this volume, difference in volume, and big W is the weight. It is the amount of coal sample originally taken. So in this way we find out the value of the percentage of nitrogen. Next we determine the percentage of ash. Now the percentage of ash is determined by the same method which is used in proximate analysis. So for proximate analysis, first of all 1 gram of coal sample is taken. Let the weight be equal to A. It is heated to 105 to 110 degrees centigrade for 1 hour, and then it is cooled. When you heat it to this temperature, as a result all the water that will be formed, moisture that will be formed will evaporate, and then this is cooled, and then it is weighed on cooling. So whatever weight comes, now from A it has converted to B. Then we take B grams and we heat it to 950 degree plus minus 20 degrees centigrade for 7 minutes. And here whatever volatile matter is present will evaporate during this heating. Then this is further cooled and this is weight. So now the new weight is equal to C gram. Now this C gram is taken, it is heated for to 700 degree for half an hour, and then in this time continuous heating, finally a constant weight will be obtained, and that will give us the weight of the ash content. So the weight, the formula that we have for the ash content, the final weight after heating and all that will be equal to d gram. So the percentage of ash will be equal to d upon x into 100, where d is the constant weight or the last weight that is obtained, and x is the amount of coal sample that is originally taken. X is nothing but equal to a, because a was the original amount of coal sample that was taken. So in this way we determine the percentage of ash. Now there is only one last thing which has to be determined, and this is the percentage of oxygen. Now percentage of the amount of oxygen is equal to 100 minus percentage of carbon plus percentage of hydrogen plus percentage of sulfur plus percentage of nitrogen plus percentage of ash. When you subtract from this, then the weight that we will get will be equal to the amount of oxygen. Now after this we will discuss the significance of the ultimate analysis. Now in this significance we will, here it is given in a very small and a brief manner, but this has to be written properly. Now in the significance, first we will take the percentage of carbon. Now as it is known to you that if a fuel is taken and it is heated, then the carbon in the fuel reacts with oxygen and converts into carbon dioxide, and large amount of energy is released, which is the calorific value. So higher is the value of the carbon, more will be the amount of energy that will be released. So as a result, the amount of carbon should be as high as possible. Second parameter is that of hydrogen. Now hydrogen also reacts with oxygen and converts into water and releases large amount of energy. So as a result, more will be the number of hydrogen, more will be the calorific value. So as a result, the amount of hydrogen should be as high as possible. Next is the percentage of nitrogen. Now nitrogen, it does not contribute to the calorific value of the fuel. On the contrary, nitrogen reacts with oxygen and converts into oxides of nitrogen, which further react with water and convert into the acids. So as a result, amount of nitrogen should be as less as possible. Next we have the percentage of sulfur. Now the percentage of sulfur also same behavior, because sulfur also reacts like nitrogen and first forms the oxides of sulfur, which then react with water and cause acid rain. So in this way, both of them, nitrogen as well as sulfur, are not contributing to the calorific value and they are contributing in the pollution. So as a result, they should be as less as possible. Next is the percentage of ash. Now as it is known to us that ash does not contribute into the calorific value. On the contrary, it stops the energy and so as a result it should be as less as possible. Last is the amount of oxygen. So for the percentage of oxygen, it has been found that wherever the oxygen amount is more, there the water content is very high. So as a result, the oxygen should be as low as possible. I hope you have understood this lecture of ultimate analysis. I thank you very much for listening to me. Thank you.